Is basically a checklist of all the types of analysis we might want to run on a particular design. I can simply choose the types of analysis and add them to my checklist, or in this case I'm going to load one that I've previously created. You can have as many different analysis or streams as you want, break them down by technology, manufacturing capabilities, pretty much however you want to. These are the types of analysis I'm going to run on this particular design. If we go over to the details, we can take a look at the individual checks that might be run. So some standard spacing type issues. If I need to change any of these, just simple as changing the value. And then of course I could resave this at this point if I wanted to as a different analysis. Drill to copper checks, drills without pads, pads without drills, acid traps, copper slivers, pinholes. So beyond just the standard DRC items, we do some of the more design for manufacturing, design for fabrication type checks as well. And those will change from layer type to layer type. So we'll do different type checks obviously on a solder mask layer than we do it on a signal layer. So I'm going to go ahead and run this, and we'll take a look at the results when it's done and see what types of items we actually did find. When there are problems, we'll get these error results message here. Click OK. It'll take us right to the errors. We can click on any error to see that particular error. It'll zoom in for us. We can annotate or add notes to any error. So if you're in a design group, you may add notes for another person to actually implement. One person might be doing the design review and another person the actual design. So things like track to pad type issues, annular ring issues, pad to drill issues, things like antennas or dead traces, we can find those. Maybe some acid traps, solder resist slivers, even copper slivers, you know, where we've over poured an area and actually come to a point there that can redeposit and cause problems in manufacturing. So all of those errors, there was one or two of them. What we're going to look at next is some errors where we have quite a few of a particular type of error. So here I plated drill to copper, I have 95 errors. If I look at this first one here, I ran it at 8 and I got 7.5. I can click on it. Doesn't really give me a lot of information other than the pad size and the drill. But what I can also do is chart these. And when I chart them, I find out that all 95 errors are the same 7.5 value. So I might decide 7.5 close enough to 8, so I'm just going to accept that. So I'll select all these, I'll right click and delete them. So I've quickly validated 95 errors without having to walk through each individual error. And the other thing I can do is I can hide these deleted items to let me know that I've already validated those. Some other things you might see, maybe some annular ring type issues. Again, we could use the charting here to narrow this down and see what the particular errors are. So I've got a few that are just slightly below what I ran it at, but I've got quite a few here at the 3.125 value, which is significantly lower than what I ran my minimum distance at. So I might decide to redefine these thermals back in the CAD system because of that. Other things that we might find on a solder mask layer, missing solder mask clearances, we can click on those. It looks like we've just left off the clearances for the vias intentionally, and as a matter of fact, when I set up the analysis I could have told the software to just ignore this, but in this case we do see that we have errors for missing solder mask clearances, which is always a good thing to see. And then things like silkscreen, to make sure we're not putting silkscreen on solderable areas. Not a severe error there, but this can help us find if there's any reference designators that might be completely removed when the fabricator does the blowout process and removes all the silkscreen from solderable areas.